Alright, this is a video on trigo identities that everybody has been waiting for. Before we start solving, let's recap the basic trigo terms. Okay, 1 over sine theta is cosecant theta. How to remember? When you see the S, the inverse of it has to be co. So when we have cosine theta, okay, the inverse of co, it will be s. So we start with secant theta. 1 over tangent, you become cotangent theta. Okay, and we have the very famous sine square theta plus cosine square theta equals to 1. Okay, this is derived from Pythagoras theorem. If you need the proof, you can read up on your text. Okay, the next two equations you can derive. How to derive? The first one is dividing sine square theta throughout the equation. So I will end up with 1 plus cosine square theta divided by sine square theta equals to 1 over sine square theta. So simplifying this will become cotangent square theta. Okay, cosine over sine is tangent. 1 over tangent. Okay, if you don't believe, you can work it out on your own. So this will be equivalent to cotangent square theta. 1 over sine is cosecant, and in this case there's a square, so it's cosecant square. So we have derived this. Second, we divide throughout by cosine square theta. We'll get sine square theta over cosine square theta plus 1 equals to 1 over cosine square theta. So tangent square theta plus 1 equals to 1 over cos. Cos, the invert of it will be secant square. Okay, so you can see that actually there's no need to memorize all the equations. All you need to do is remember this, the rest, the top three, and then you derive by dividing sine square and cosine square. Okay, now let's start solving questions. Oops, let me get a pen. Okay, so when we do trigo identities, it's a good thing that we always start from the complicated side and we try to reduce it to the less complicated side. Okay. Okay, over here we need to say where is the left hand side, right hand side, and which side you wish to start from. So by my habit is start from the left hand side because usually it's more complicated. So over here, before you begin, you need to analyze this. I must change from a sine to a cosine, and the only way to do that is by using this identity. Okay, so I need to change that. Sine square is equivalent to bringing cosine square over, so it will be 1 minus cosine square theta, or in this case is x, so do follow the angle. So x, okay, expand this out because here we have -3. We want to get the -3. After we multiply in, we can see that the -3 will come out. Okay, and we have proven this. This is the same as the right hand side, and thus proven. Okay. Oops. Okay, now let's move on to part E. Okay, before I start, let me write down the identities first. Okay, sorry, there's no square. It's important that I write all this down because I can always refer to them by the side, and it will help me to see a pattern and eventually help me solve the identities. 1 over tangent is actually secant cosine over sine. Okay. So the next one, the very famous identity. The next one will be derived from dividing sine square throughout. One. Okay, see, I don't need to memorize, I just need to work it out by dividing sine square. Next will be dividing cosine square. Dividing cosine square. Sorry, this is dividing cosine square. So see, next one dividing sine square. So this will be cotangent square theta because cosine square over sine square will be cotangent. So 1 over sine is cosecant. So cosecant square theta. Okay, so we can start. So as you write this down, you'll notice the left hand side is more complicated. So later on, we'll start from the left hand side and work our way to prove the right hand side. Okay, left hand side is this. Trigo identity proving, I can say, is the simplest in trigo because you don't have to find the angle, you don't have to sketch, just prove. Okay, so from here, I want to highlight that many of you have a tendency to open up the bracket. But before we do this step, we need to look at what we are having on the right. It's a tangent square x. If we expand this out, we can't get a single term. Okay, so in order to get a single term, we have to continue and factorize. So I notice that I have a sign in front. In order to get tangent, I might need to have something in the denominator as cosine x. I'm just guessing. So in this part, I'm trying to factorize more, make it simpler. So I do not go and introduce, go and expand and introduce other things. So this, I see a pattern in my identity. So this will kick in. So I replace that with secant square x. So you notice we are going to get simpler and get tangent square x. So we don't want to have, we need to have some denominator. So this will help us to get the denominator. So will be sine x over, oh sorry, I missed out the square for the other term. Okay, s, so the inverse will be cosine square x. Okay, there you go. See, you have proven this will be equals to the right hand side. Okay, proven. Done. Next. So again, it's a good habit to write down the identities, but since I already know them, so I will not write that down. Okay, as I copy down the question, I notice again the right hand side is simpler, so I will start from the left. Okay, I start from the left hand side, the right hand side. Yep, proving trigo identity is very kind of tedious, but it's a no-brainer thing. So again, I see a linear term. Here I see no bracket, so the best thing is to make it simpler, simplify. So 1 plus cotangent x square x, I know the identity, this belongs to cosecant square x and cosine x. So you can see I'm very near. Okay, maybe I just make this into this form. Okay, I have this. This is the one I've split up. Okay, so I can see that this term somehow will become cotangent at x. So if we just change this, this will become 1 over sine x. Okay, and you can see magic. This is cotangent x. Okay, we have proven. Okay, and done. So that's all for the simple trigo identities. Thank you for watching.